Hello everyone, this is lab 13, acceleration and the velocity vectors, learning by play. All right, you start from this link, and then we will start to explore the nature of velocity and acceleration and their relation and in various type of motions. And you will use this 2D simulation. Okay, you click here, control click, you start the application. Once you start the application, you will see this. There's a dot, and as we discussed in class, your hands is apply a force. And what is the force? And you're right, push and pull. So your hands, you grab the ball, pull and push and push. So as the ball is moving, and then there you see the two arrows. One is blue, one is green, and these two are, one is indicating the velocity vector, the other is the acceleration vector. So then just play with it and make it uniform motion, make it constant motion, and make it stop, and then let it drifting around, and make it go like a circle by your hand. And so there are two arrows representing velocity vector and acceleration vector. So now the first question to you is to realize, by looking at it, observing it, which one is the acceleration vector, which one is the velocity, and then here are the two questions you need to answer. Which vector represents the velocity, blue or the green, and which vector representing the acceleration? Now let's look back again. So you see, velocity is where the object goes. Looks like, the green arrow point to where it goes. But acceleration is point to where the velocity changes. So it could be, may both be in the same direction. But you see, when it stops, the blue goes the other way. So that's the acceleration. When it go acceleration, and so when it turns, the velocity changes in the way that changes, in the direction it changes. So it looks like, what do you think? The green is actually where it goes. The blue is where it changes, where the green changes. All right, so see this. So you go here, and then blue turn the other direction, which means deceleration. You go same direction, and then when it stops, the blue go the other way, and then that blue make the green shrinks. So then you play with this, and then that blue make the green turn. Okay, turn that direction. If you go this way, and the blue points to the direction that thing, just play with around. So now I recognize, I think, what do you think? Yes, you're right. The green is the velocity, where it goes. The blue is where the green changes. Okay, where the green changes, where the velocity changes, that's the acceleration. Now we know this green is the velocity, blue is the acceleration, which is right down here. Linear motion, click linear acceleration, at the bottom, and leave it, let it simulate, let it drive it. Take a snapshot when the ball is speeding up. Insert here. Okay, insert the snapshot. That take a little tricky. That's the computer trick, but it's not hard to do. People did that. Take a snapshot. Take a snapshot. Take a snapshot, and when the ball is slowing down, so snapshot speeding up and slowing down, and hit stop and use your hand to mimic the situation. Write it down here. You don't need to do. Okay, when you're done, insert snapshots and insert write done here. and click the linear acceleration. You see, whoa, it's accelerating, see, and then when that slow down. And accelerating both in the same direction as when it slows down at the moment. So basically, there we go, snapshot, speeding up, and then slowing down. Okay, see, slowing down is when it's slowing down. When it's slowing down, the acceleration goes the other direction. So you have to be quick and take a snapshot, see if you can. Or you may use a camera, or you may do the screenshot. And so that's it. When you're done, you take a snapshot of this moment, and then take a snapshot of this moment, okay, when it's slowed down. Speeding up and slowing down, insert a snapshot there on the screen and put stop. Number 2 is the acceleration and the velocity are linear or inline or opposite or inline, but they at least in the same direction. But number 3 is the curvy or circular motion. Click the circular motion, see a simulation of the circular motion. Observe the magnitude and direction of both velocity and vectors. Take a snapshot when the ball is in circular motion, right? So you will see that the velocity and the acceleration are in different directions. In fact, the acceleration is towards the center of the motion, while velocity is along the tangential line. Hit stop and may make this by hand, doing it by hand. Optional, take a video if you can, insert here. Well, if you don't want to, at least take a snapshot. All right, it is required a force to keep an object moving along a circular path. Which direction must be the force be in? So you can use your general experience, or you can sort of feel it here. Require a force. Your cursor and your mouse is the force. To make it go along a circle, which direction the force must be in. All right, so you answer this question. These 2 require you to take a snapshot, and this third C requires you to answer the question after you play with it by hand. So number 3, so you click circular over here, and then it will go by a circular motion. So then you see when it goes to a circle, the speed is where the green goes. And then you have acceleration. Acceleration will be velocity change. Okay, the blue point to, okay, go ahead, change to that direction, change to that direction. So therefore the green, the velocity changes in that direction, right? Take snapshot here or take a video here, very short, and that's the thing. The acceleration is towards the center. Then stop. Now you do by hand, try to make it circle. Whoa. Okay, make it faster, you see. Look like it is so the velocity is green, but acceleration is always to the side. It is a pointer says go that way, go that way. It's like telling the velocity to go that way. So go that way and go that way, or tell the velocity to go, the blue telling the green to go which direction. That's the acceleration, right? So if your hand is the force, the acceleration is towards the center. Okay, number 4 is the simple harmonic motion. Other than it's back and forth motion, it's like harmonic. And you see this motion sometimes, like swing in the playground, or the guitar string vibrating if you look at it very closely, or a pendulum in a swing back and forth, back and forth. That's the back and forth. That's called a simple harmonic motion. You can see many types of this motion in time, many places, right? You could give an example. All right, so first we're gonna observe the motion by playing this, pay attention to the timing between the velocity and acceleration vector, okay? Once again, observing very closely, pay attention to the timing between the velocity vector and the acceleration vector. All right, so and then hit stop. So then you do here, we have a simple harmonic motion. Basically, we'll let it go by itself. All right, so it goes this way. So swing back and forth. You see the acceleration goes. So sometimes in the same direction, sometimes in the opposite direction. Swing back and forth, basically like a swing. You see the acceleration sometimes is in the same direction, sometimes. Just think about a big swing, slowly going back and forth. The velocity is always in the same direction of where it goes. Well, the acceleration is when it is changes. The green there, that's a relation. So they see. All right, so you see that. So they're not always in the same direction, but not always in the opposite direction. They have they're both going up and down, back and forth, but they say actually they're going with sine and cosine curve, up and down, but they are, well, what we say is in a different phase, out of phase. Okay, if you describe them with the sine and cosine function, and they both are sine and cosine function, up and down, left and right, but they are different in the phase of 90-degree angle. So you see, it's like one chasing the other one. So that is, so now if you answer this question, observe the acceleration vector and hit stop, okay, and think a moment. Let's hit stop. So, and to answer this question, okay, at which moment the velocity is 0, and there is still acceleration, velocity is 0, and so you think, okay, look at, then let's do it again. Okay, so velocity is 0, and there's still acceleration when you go here, then boom. Okay, the green shrink to nothing, it's not moving, but then there'll be acceleration going, which means go that way. All right, so and left and right side, when it stopped, the green shrink to 0, and then the acceleration say that way. And so observe, the green becomes 0, and the green becomes 0. The acceleration actually is maximum. Okay, and then if I ask another question, where the velocity is strongest in the magnitude, actually it's in the middle. Okay, when the swing goes to the middle, it's fastest, the acceleration actually goes to 0, and that's the time the acceleration changes directions. All right, so the answer is at the turning point, that's one moment. We have a question, when it becomes 0, okay, at the turning point. So this is like a swing through something in the air at the maximum point, and then you have velocity 0 momentarily, okay, only for a moment. Okay, so here 0, okay, then go in that direction, and then the acceleration is maximum at either side. So at which point the velocity is 0 on the either side when velocity stops, when it swing back, yeah, and the big acceleration but 0 velocity, but only for a moment. All right, so now, and once you have this experience, and then you look at the snapshots, matching the snapshot of the object moving, which picture describe which situation. So you're matching A, B, C, D, E, F, G, H, I, J, K. So you have like 10 situations. So that's what I made a snapshot. Just play this game. This is actually in one of the questions in the final exam for the lab. All right, so you see regular motion, which means constant velocity to the right. Think about it. Which one? Which means there's no, basically no acceleration, or virtually no acceleration, okay, and but the constant motion, and then, for example, to the right, regular motion. So which means if the green is the velocity, but the blue should be no blue. Which one has no blue? That one. So J. So you put J here. I will not give out the answers here, But then after the above exercise, it's pretty easy to identify which one goes which one goes which. All right, if you really are in trouble, and you can always talk to your instructor. Okay, that's the last question or last thing you will do for this lab. Hope you enjoyed and understand the relation between the force and acceleration and velocity, and they are both vectors. All right, remember, vectors.